Now next paper is second variant of paper 6, October number 2025. Question number 1. Eggshells are made from a mixture of calcium carbonate and other insoluble substances. We have this reaction between calcium carbonate and HCl. We have already seen this reaction in your literature. The other substances in eggshells do not react with the dilute hydrochloric acid. A student finds the percentage by mass of calcium carbonate in an eggshell. We have these steps to find the percentage mass. Step 1, grind the shell into smaller pieces. Okay, then find the mass of the smaller pieces eggshell, and then add eggshell to the excess hydrochloric acid, warm, stirred with a glass rod. Describe what is seen when the calcium carbonate in the eggshell reacts with a hydrochloric acid. So what you look at when the reaction is there between the eggshell and the hydrochloric acid. And this is the reaction. So during the reaction, what you can actually see, what is happening in the reaction. So the formation of carbon dioxide is there, but you do not say the name of the gas. That will be wrong. You cannot state the name of the gas. Rather, you will say the observations because of the gas. So that is fizzing. Fizzing is seen, or bubbles. Either you say fizzing or you say bubbles. Then part 2. Describe what the student should do to make sure the acid is in excess and all of the calcium carbonate has reacted. So for complete reaction to be done, you can either add some more amount of the acid, and if the bubbles are not further produced, it means that acid was already in the excess amount. You do not know actually how much volume of the acid you had used here. Maybe it was less, but to confirm whether your results are correct, you will let that reaction to go further, and after a while, if you see that bubbles have stopped producing, you can add more amount of the acid. Once the bubbles stop producing, when the bubbles stop, you can add more HCl. And if no more bubbles produce, then it can confirm you had already added the excess, and no more bubbles produced, it can confirm that the excess acid was already used. The other way is that you can, since the reaction is occurring between the calcium carbonate and acid, it is also producing the salt, and this is also a salt. They have their some sort of basic property as well. They are slightly basic as well. So if both acid and basic are there, you can use a universal indicator. The universal indicator that will give the observation in the form of the color. The universal indicator provides red color in the acidic medium. So if it is red in color, it means you have added excess amount of the acid. So you can write here universal indicator used, and red color given gives the confirmation that you have used the excess amount of the acid. Then part B, after step 3, the student filter the mixture to obtain the unreacted solid left from the eggshell. Draw a label diagram of the apparatus the student should use to filter the mixture. So filtration has been already studied in the literature, we are supposed to separate the solid from the eggshell and the mixture, because this is what we are doing here. We are doing the reaction. There is also a solid over here, and some of the pieces of the eggshell might not have reacted, so they will remain there in the form of the solid, and the liquid part is belongs to the acid. So we have to separate the solid from the liquid just to get the calcium chloride out. The calcium chloride is supposed to be filtered. So simple apparatus for the filtration is draw a funnel, conical funnel like this, and also show the filter paper present inside of the funnel with another layer. The second layer over here will be for the filter paper present inside of the funnel. So that's it. You have this picture, and you can also label them. This is the funnel or conical funnel, and this one is filter paper. Part 2. After the filtration, the student watches the residue. Identify the two substances removed from the residue by washing. So residue, as you know, is a solid part here, and we have the excess amount of the hydrochloric acid present in the liquid. We have to identify those two things which are present in the residue. One is the HCl. HCl was present in the excess, and the other one is calcium chloride. Calcium chloride is also in the aqueous form. These two things are separated from the residue. Calcium carbonate remains in the solid form. Gas has evolved into the atmosphere. H2O will always remain as a solution of the calcium chloride, because H2O is providing the solvent for the calcium chloride solution. So you can say uh, calcium chloride, CaCl2. This is removed. Then part 3, after washing the residue, the student dries the residue in an oven, and these are the observations. Use the data in table 1.1 to calculate the percentage by mass of calcium carbonate in the eggshell. So here comes the calculations part. According to the calculation, we have to find the percentage mass of the calcium carbonate in the eggshell. So mass of small pieces of eggshell was 2 gram, and the mass of dry residue after filtration was 0.11. So we know eggshell is basically made up of calcium carbonate, CaCO3. So the smaller pieces after drying the residue, it contained the CaCl2. The residue was CaCl2. We have to subtract the mass to find the mass of the calcium present in it. So it will be equal to 1.89 gram, and divide this value by the total mass of the calcium carbonate. 1.89 divided by 2 gram. Since it is percentage, so you multiply this value with 100. So the answer will come out to be 94.5%. So this much amount of calcium carbonate was present in the eggshell. Actually, the rest of the mass was left out in the form of the carbon dioxide and water. This thing and this thing, these are separated out from the mass of the calcium carbonate. So this is how we are able to identify how much CaCO3 was present in the eggshell. We have done question 1 of this paper. I will complete the remaining portion of this paper in the next class. So that's it for today. If you have any question,